Okay, so let's continue working on our review for the final. It says a hawk sees a mouse while flying at a height of 124 feet and begins a dive towards the ground to catch the mouse. What is the hawk's height in centimeters when it begins to dive? And they tell us that 1 inch is 2.54 centimeters. Of course, that's not the only piece of information we're going to need to know. We also need to realize that we know that there's 12 inches is equal to 1 foot. So we have two relationships that are going to be important to go from feet to centimeters. We'll need to go from feet to inches and then from inches to centimeters. Anytime you want to convert a measurement, we start with the measurement that we're given. We're given 124 feet. So that's where we begin. 124 feet. And then you're going to multiply, and you're going to multiply by a fraction. The trick is what goes on top, what goes on the bottom. Now you can draw it like this, where there's a multiplication dot. If I want inches instead of feet, I want my feet to cancel out. I prefer to actually do kind of the box method, like this. 124 feet. I want inches, so I'm going to put 12 inches on top of 1 foot. Essentially, 12 inches and 1 foot are equal. It's almost like a very fancy way of multiplying by 1. Notice when I do that, that foot will cancel out with that foot. Anything divided by itself will cancel out. So that's going to give me the answer in inches. And now I just want to continue that so that I can change it to centimeters. 1 inch is 2.54 centimeters. I want the inches to cancel out, so I put the 1 inch on the bottom and the 2.54 centimeters on the top. Again, when I look, I can see that inches cancels with inches. The rule is you multiply by everything that's on the top, so we multiply across the top, and then we will divide by what's on the bottom. Well, in this case, the only thing on the bottom is 1, so it's not going to change anything. So 124 times 12 times 2.54, and we get an answer that's 3,779.52 centimeters. Now, they may ask you to round that to the nearest centimeter. If they want it rounded to the nearest whole number, that would be right here. You would look here and say, okay, round that on up. That would be 3,780 centimeters. They might not, but you should look at those, read those questions carefully, because sometimes we're missing things, not because we did the work wrong, but we didn't write the answer with the correct units or rounded to the correct number of significant digits. So, worth paying attention to. All right, our next problem uses that formula for blood alcohol content. It says a male driver is stopped by the state police for driving erratically. The driver, who weighs 215 pounds, had 4 12-ounce beers and 3 1.5-ounce shots of liquor 4 hours before being stopped by the state police. Find this driver's blood alcohol content to the nearest thousandth. So they've given us a formula. We need to fill in a lot of information. Let's start with the number of standard drinks. Well, there's 4 12-ounce beers and 3 1.5-ounce shots of liquor. That's a total of 7 standard drinks. So we know that N is going to equal 7. The weight in pounds, they tell us he weighed 215. So this will be 215 pounds. The gender constant, they said it was male, so our gender constant is 0.68. And the number of hours since the first drink told us shots of liquor 4 hours before being stopped. So that is going to be T equal 4. This is pretty straightforward. We just have to plug everything in and be careful that we're using our calculator correctly. Negative 0.015 times T is 4, plus 2.84 times N is 7, over W was 215, times G is 0.68 for a male. We might want to make this more obvious. This is a big bracket here. So we just need to use our calculator. Negative 0.015 times 4. This part is basically telling you how much has had time to get out of the system. So he's gotten a little out of his system, but not near as much as what he's put in. 2.84 times 7 divided by 2, 17.68. This is 0.13. They said us to round to the nearest thousand, so 0.135. And his blood alcohol was just barely under the legal limit at 0.075. You'll recall the legal limit is 0.08. The next problem is to find the body mass index for a person who's 6 feet 4 inches tall if they weigh 265 pounds. You need to remember, and they don't emphasize this here, for the body mass index, our height needs to be in inches. So the height here, which was 6 feet 4 inches, we need to change 6 feet into inches. So we have to do 6 times 12, that gets us that in inches, plus the 4 additional inches. That's a total of 76 inches. 6 feet tall is 72 inches, so plus the 4 more. The weight is already in pounds. He's pretty heavy at 265. So we're going to have 265 divided by 76 squared, and then times 703. 265 divided by 76 squared times 703. This is a BMI of 32.3. I'm not looking at the chart. That's definitely overweight. Whether it's just considered overweight or obese, probably obese if I had to guess. I think that's going to be considered more than just overweight for a man. So even though he's fairly tall, that was just a little too much weight. All right, it says solve the formula 25 equals x over m squared times 45 for x. So let's write our formula. Want it a little bigger so we have a little more room to work. 25 equals x over m squared times 45. And we want to get x all by itself. Our goal is to get this x alone. So we go step by step, making changes. The first thing that I kind of want to do here, there's a couple approaches we could do. And I'm kind of having a mental debate with myself what's going to be easy. Since we are multiplying by 45, why don't we go ahead and divide by 45? If I divide by 45, and I'm not even going to work that all the way out. Here's our kind of our imaginary line that equal. This side is going to look like 25 over 45. And this side, once I divide by 45, looks like x over m squared. Anytime you see something and it looks like a proportion, we have the option of treating it like a proportion. We can cross multiply to solve that. We can say 45 times x, that's 45x, equals 25 times m squared. So how do we finish solving for x? Well, we just need to divide by that 45. So if we divide by 45 on both sides, we get x equals 25 over 45 m squared. Now, I haven't done that division. If I do it on my calculator, I get a real long repeating decimal. So that's not ideal when you're solving an equation. So probably what we want to do is just reduce our fraction. I know that I can divide 25 by 5 and I can divide 45 by 5, and I'm going to get 5/9 m squared. Okay, so we got a lot of questions here with Bubba and the rock selling business. It says, Bubba sells rock kits at a local rock and fossil show. The kit contains a custom wood display box and different types of rocks. All of the rocks have the same cost. The table shows how much some of the kits would cost. Kits with 3 rocks are $25, so let's fill that in. Whoops, a little screen jump there. Kits with 4 rocks are $30. So right there, we can see that when we add a rock, it costs $5 more. So 1 rock, when I go up 1 rock, I don't know why that keeps doing that. I go up $5. Okay, so let's think about this. We got to fill in some more information. From 4 to 7, that's 3 rocks. How much is 3 rocks going to cost? Well, if 1 rock is $5, 3 rocks is going to be $15 more. So that's going to actually be 45. And of course, when I go from 7 to 9, that's 2 more rocks. Remember, each rock, we've already figured out what that slope is. This information right here is telling us that it costs $5 for 1 rock. Because adding 1 rock brought that price up. So if I add 2 rocks, it's going to be $10. So this will be 55. So we can see we've got the slope. It says, look at the first 2 data points. What do they tell you about? Let's see if I can get that. What do they tell you about? There we go. The cost and the number of rocks. That tells us right off the bat that the cost is $5 for 1 rock. That's our slope. It says, how much would you pay for the custom wood display case if you didn't want any rocks? That really requires us to fill in the rest of that table for no rocks. So let's make a bigger table. think that just helps us see exactly what's going on. So rocks and cost. This is a number of rocks. We want to know what 0 rocks is going to be. We don't know 1, we don't know 2. We know 3 rocks is $25. We know 4 rocks is $30. We could keep on going. 5 would be 35, 6 would be 40, 7 would be 45, 8 would be 50, and I ran out of room, but 9 is 55, and we've got that right here. So we have this table. So just subtract a rock off. Every rock is $5, so this would be $20. This would be $15. So if you didn't get any rocks, it still costs $10. So the custom wood display case obviously cost $10. That's how much you would have to pay even if you didn't want any rocks. It says use the 3rd and the 4th data points to find the slope. I assume they're talking about up here. Here's our 3rd and 4th data points that they gave us. They gave us 4 data points. If we use this, remember, slope is change in y over change in x. The y went from 45 to 55. That's a change of $10. The x went from 7 rocks to 9 rocks. That's a change of 2 rocks. And that gives us that same $5 per rock. It does not matter whether you use the first 2 points, which was really obvious, or whether you use later rocks. It says write an equation that represents this linear relationship. All right, this linear relationship tells you that the cost, which is y, is equal to, first you pay for the display case, which is $10, plus then you pay for the number of rocks. The rocks are $5 each, so $5 times x. X is the number of rocks. If you could afford to pay $95, how many rocks would be in your kit? Think about that for just a minute. If you can afford $95, let's look at our equation. Y equals $10 for the kit plus 5x. So if we can pay $95, if we're willing to spend that much, that will be 10 plus 5x. Let's do our equation solving. Let's subtract that 10. So we have $85 that we can actually spend on the rocks. The rocks, of course, are $5 a piece. So if we divide that by 5, I'm running out of room, but I'm going to squeeze it in. 85 divided by 5 is 17. So you could actually afford 17 rocks. You can do a double check if you want to, but I think if you think about the formula, it's going to be $10 plus $5 times 17 rocks. That comes out to be $95. So when we check it, it makes sense. Whoops, I didn't mean to do that. Let's see. All right. A local fencing company charges customers $3.40 per foot, plus a fixed cost of $250. This cost can be modeled by the equation 3.40x, so there's the slope part, plus 250. So where C represents the total cost and X represents the number of feet of fencing. If the total cost is $925, how many feet of fencing was installed? Very straightforward equation. Here we go. C equals 3.40 times X plus this $250 of fixed cost. And they're telling us The cost in this example is $9.25. So after we subtract the $250, which if we're using our method, that's the logical thing to do. We're trying to get this X right here all by itself. So in order to do that, I want to subtract off 250, minus 250. That's that fixed cost. So $925 minus 250 is $675. And that's going to equal, over here, of course, 3.40x plus 250 minus 250. This side is just the 3.40x. So now we can divide to get x by itself. So we have to do the same thing on both sides. That's why I kind of draw that imaginary line. So you'll remember these two sides are equal and I have to keep them equal by treating them the same. So x equals 675 divided by 3.40 comes out to be 198.5. If we were rounding that up, we might say it was 199. Let's see. All right, you want to buy a boat for fishing and find a boat that will cost $17,400. You'll need to borrow some of the needed money from your bank. Your bank will loan you $9,500 using a simple interest loan, but you will need to pay back the money over a period of 5 years, including an interest rate of 6.5%. How much interest will you pay? Well, simple interest, that's the easiest kind, is given by the principal times the rate times the time. So our interest will be $9,500, that's the amount of money that we are borrowing. Our rate is 6.5%, but we have to make that a decimal, so 0.065. We divide by 100, that's what percent means, divide by 100. And the time period is going to be 5 years. So simple interest is not fancy. 9,500 times 0.065 times 5 years is, gosh, that seems like a lot, $3,087.50. So about $600 and something a year just in interest at 6.5%. So how much interest will you pay? That is the interest. That means that that boat that you thought cost $17,400, by the time you add in that interest for that extra, we'll just round it up. That boat actually cost you over $20,000 because you had to borrow. Anytime you're borrowing money, you need to keep in mind that whatever you're buying is going to cost you more because of that interest. Now, this next problem has to do with compound interest. It says Raphael will deposit $7,500 in a local bank and will leave it in this bank for 4 years. The interest rate will be 7% and the interest will be compounded quarterly. So 4 times a year. Every 3 months they're going to compound. Here's our compound interest formula. It's a little different than the one that I showed you, but the one that I showed you said it was going to be this. But essentially, it's the same thing. They're saying, look, you've got to get the rate and divide it by the number of compounds per year. So in this case, the interest rate is 7%. So 0.07, and they are compounding it 4 times per year or quarterly. So if you do 0.07 divided by 4, your quarterly rate is 0.0175. That's how I did it. I went with just putting in the quarterly rate. So that's the quarterly rate. And then this number, NT, is the number of quarters. There are 4 quarters per year times how many years? 4 years. So there are 16 quarters. Quarters, so that's what they're doing here. They're multiplying N times T. All right, so we're going to actually calculate $7,500. 1 plus 0.0175 for 16 compounding periods. 4 periods a year for 4 years, that's 16 periods. The quarterly rate is the annual rate divided by 4. So 7,500, 1.0175 to the 16th power. They will pay back, or well, it's not paying back. He will have $9,899.47. So he will have earned almost $2,500 in interest. You earned a lot of interest because he got a good rate, but also because they were compounding it more frequently. Let's do one more of these compound interest problem. It says, suppose you invest $12,000 into a certificate of deposit with a 10-year term that pays a 7% annual percentage rate. The compounding period is 1 year. So this is the simplest case. So we don't have to multiply to find out how many periods, and we don't have to divide to get a monthly or a weekly or a quarterly rate. It says, how much will he have at the account at the end of the first year, at the end of the second year, at the end of the 10-year term? So here's how we calculate the amount. The amount, here's our formula, is the principal, which is $12,000. 1 plus R, 7% is 0.07. And then we're going to do it for the number of years T. So our formula is amount equals 12,000, 1.07. We can go ahead and add that together. And we just have to plug in different numbers of years. If I plug in 1 year, I get 12,000 times 1.07. That's going to be 12,840. So that's the answer to part A. If I do it for 2 years, it's going to be 12,000 times 1.07 to the second power. I'm going to multiply by 1.07 again. That's going to be 13,738 and 80 cents. If I do it again where I'm doing 12,000, 1.07 to the 10th power, I get 23,605.82. So he has almost doubled his money in 10 years. Not quite, but almost. The recipe has a ratio of 2:1:4 for flour, sugar, and eggs. If I have 28 ingredients, how many of them are eggs? I find that kind of a poorly phrased question, but I know what they mean. So I'm going to make a table to show you how to work this. We know there's a ratio for flour, sugar, and eggs, and that ratio is 2:1:4. It really helps in a problem like this to also have a total. 2:1:4 is 7. They are telling me, if you want to think of this table kind of column-y, that this number is 28. That's what they mean. I have a total of 28 items, 28 somethings. How many of them are eggs? So what is this? That's the question. 4 is to 7 as x is to 28. If you're good at proportions, you may look at this and say, well, 7 times 4 is 28, so 4 times 4 is, I think x will be 16. But if you're not as intuitive, you cross multiply. 7x, 4 times 28, and then you'll have to divide by 7. I'm going to wait and do my math last. So I end up getting 4 times 28 divided by 7, and I get that it's 16 eggs. It says an animal breathes approximately 6 times per minute. Better write that down. 6 breaths in 1 minute. That's what that problem has told me so far. About how many seconds would it take to breathe 1 million times? How many hours would it take to breathe 1 million times? All right, there's a couple of ways to approach this. I want to approach it like a proportion, but I look at part A and they're interested in seconds. I know that 6 breaths, and I'm going to abbreviate with a B, in 1 minute. Well, 1 minute is the same thing as 60 seconds, isn't it? So there's 1 breath every 10 seconds. Isn't that exactly what 6 breaths in 1 minute tells you? 1 minute is 60 seconds. You're taking 6 breaths. That's 1 breath every 10 seconds. Let's do a proportion. 1 breath in 10 seconds. I don't know what I touched that makes that pop up. Equals how many breaths? No, we know how many. 1 million breaths. And I think I'm not even going to put 1 million breaths in x seconds. 1 breath takes 10 seconds. 1 million breaths takes how many? If you want to cross multiply, you can. You may already know the answer by reasoning, but basically if you multiply this, you get 1x. If you multiply 10 times 1 million, you get 10 million. 1 million breaths takes 10 million seconds. Why? Every breath takes 10 seconds. If I want to breathe 1 million times, it's going to take 10 million seconds. Now, the second question is, how many hours would it take to breathe 1 million times. We can approach this a couple of ways, but I think the easiest thing is to say, hey, you know what? I just need to change 10 million seconds and see how many hours that is. I know how long 1 million breaths take. So if I start with 10 million, and I want to write the 10 million out this time. 10, that's 10 million seconds. And I want to know how many hours that is. Well, first, I have to know that 60 seconds is 1 hour. Nope. 60 seconds is 1 minute. And 60 minutes is 1 hour. We're going to do it in a two-step process. I want to change this to minutes. 1 minute is 60 seconds. That's going to let me cancel out the seconds. So if I want to change seconds to minutes, I end up having to divide by 60. 60 minutes is 1 hour. So 1 hour is 60 minutes. Again, now the minutes cancel, and I'm only going to be left with hours. The alternate way you could have done this problem is you could have used the fact that 1 hour is 3,600 seconds, but we did it the long way. So 10 million. Make sure you have the right number of zeros. It should be 7 zeros divided by 60 divided by 60. We have to divide by everything that's on the bottom. It comes out to be 2,777 the sevens repeat, so I'll just put 0.8 hours. And that was the very last problem on the review. Hopefully that's going to make you feel a little bit more confident going into the final.